Hey everyone, thanks for tuning into In Space today. I am Noor and this is the first episode in a new series about containers on the cloud. We will briefly explain containerization topics and directly jump into real-world examples. This series is not meant to replace any online courses, rather than offering a quick start guide for those interested in the topic and want to try things out. In each episode, we will have new concepts to learn, list of objectives to achieve by the end of the episode, and a summary of the new commands that we learned in the episode. Are you ready? Let's get started. The first thing we want to know is that there is a difference between containerization and virtualization. I will read to you the definitions by Google. Containers offer a logical packaging mechanism in which applications can be abstracted from the environment in which they actually run. For a virtual machine, it is a guest operating system, such as Linux or Windows, runs on top of a host operating system with a virtualized access to the underlying hardware. What does that mean? We can see in the following image. As you can see, in a virtual machine, we have the infrastructure, we have the host operating system, on top of that there is the hypervisor, and then there are multiple guest operating systems, each which has binaries and libraries, and then comes our application. While for containerization, we have the infrastructure, the host operating system, then a container runtime, which is in our case would be Docker this time, and then there are the binaries and the libraries, and then the application. There are different use cases for virtual machines and containers. I will not go into that. You may read about it. We will just talk about containers. When we talk about containerization, we are often talking about Docker. There are, however, few Docker alternatives that we will list in a minute. So what is Docker? Docker is the vessel by which container images are packaged and delivered. This automated process produces images, effectively templates, which may then be run anywhere, on premises, in the cloud, or on a personal machine as a container. So let's discover Docker architecture. As you can see, there are three main components: registry, host, and client. Registries are locations from where we store and download images. Docker client is how users interact with Docker. Docker client can reside on the same host or on a remote host. On Docker host, we have two main things: Docker daemon and Docker objects. Docker daemon is responsible for all container-related actions and receive commands via the CLI or via REST API. The objects are used to assemble an application. Apart from networks, volumes, and services, which we will be talking about in later episodes, the main two objects are images and containers. Images are read-only templates used to build containers. Images are used to store and ship the application. Containers are encapsulated environment in which applications are run. A container is defined by the image and the configuration options. As I mentioned before, there are a few Docker alternatives. We have Rocket, LXD, Linux Server, Windows containers, and few others. You may check the link in the description below to read about them and check their use cases. Now that we have an idea about Docker and its architecture, let's see the objectives for today's lesson. Installing Docker, running Docker containers. Are you ready? It's shell time. If you haven't checked the video from last week on how to create and access your virtual machine, please do so, because today we will be using that virtual machine to install Docker and run containers. I have already done that, so I will just SSH into that machine and start the installation. There are multiple of ways that we can install Docker depending on the operating system. You can see the list here. There are a list of commands that you can follow, but I will just use the convenience script as it does everything for me. I'll load the file. The second command, since I am root, I don't need to use sudo. This should take some time, but it should install Docker. I'm using Ubuntu on this machine, so you may want to use that as well. I will come back to you when Docker is installed. It is still installing. In the meantime, I just remembered that if you are on a Windows or Mac and you want to install Docker locally, there are binaries that you can download and install Docker for Mac or Docker for Windows. This is an easy way if you want to develop on your local machine and try things out. It seems that we are done. Since we are root, we don't need to execute this command. Normally, if you execute Docker, it will ask you for permissions, but since we are root, that should be fine. To check that Docker is installed successfully, let's try to run our first container, the hello world container. We execute the following, so docker run hello world. It's now pulling the image from the registry and running it. As you can see, hello from Docker. This message showed that your installation appears to be working correctly. Congratulations, we have Docker installed and we ran our first container. In the recent versions of Docker, every command where you are able to do Docker run, you can also say Docker container run. So let's try that. It has the same output. It's just a shortcut whether you want to mention container or not. Since we are working on containers, so it makes sense. Let's try to run something more interesting now. I would go with Nginx. So docker run Nginx. Notice that Nginx publishes the port 80 by default. So we want to publish that port from the container to the host. So when we access the port 80 on the host, we also access it on the container. For that, we need to pass this option, which is publish, then 80. We can also pass another option to run the container in a detached mode. So -- detach. This will make sure that when we run the container, it will run it as a daemon. We can see the running containers by issuing the following command, docker ps. As you can see, we have the image nginx. This is the main command taken from the Docker file. It's up, and any traffic that goes to the port 80 on the host will be directed to the port 80 on the container. Let's check that out. So if we take the IP of our host and we go to the web browser and we put that IP, we have nginx. If we stop that container, we should not be able to access Nginx anymore. To stop a container, we need to know either its name or its ID. It's also enough to know the first few digits of the ID. So we try to say docker stop 38. That should be enough. Now if we docker ps again, there is nothing. We can see the stopped container by issuing docker ps -a, which is all, or -- all, and we see all the containers that we ran before. They all exited for different reasons. Now if we navigate to the web page again, there is nothing. We managed to successfully stop the container. We can also remove it completely, so we don't even see it when we issue docker ps all by issuing this command, docker remove, and again, either the container ID or the name. So the ID was 38. Now if we access docker ps -- all, we don't see the container here. We can achieve that automatically by passing the -- rm options. Let's try to do that. So if we say docker run -- rm nginx, sorry, we also need to publish the port 80. This time we will not run it in a detached mode, so once we exit, it should also remove the container. We check the website, we have nginx running, we exit the and we can also see the logs. We exit the container, we issue docker ps -all, or we can -a, and we see that the container was automatically removed after exiting. You can check all the options that you can pass to docker run by going to the website. I suggest that you do so. There are a couple of handy options that you can utilize. And in this lesson, we will mainly focus on the basic ones that you need to run containers, stop containers, and so on. There is also a nice option that you can name your container. Let's empty the screen so we don't get the auto-generated name. So we say docker run --name web --publish, or you can also use the shorthand, which is -p, the ports that you want to use, and then nginx. Let's try to run that in a detached mode as well. --detach or -d as a shorthand shortcut is already in use because we ran it already and it's still there, so we need to remove it first. So docker remove web, and then let's try to do that again, and we have it. If we issue docker ps, we see that it's running, and this time it's called web. This way it's much easier for us to know the name rather than the ID, so we can issue other commands like stopping the containers, removing the container, and so on. If we go back to our website, the website exists. We go back and we say docker. If we try to remove a running container, it will not allow us to do so because it's already running. We can, however, pass an option to force it. So remove -f or -force web. Now it's removed. Docker ps, not there anymore. Docker ps -a, also not there anymore. Each of the container and the host operating system have their own files. We can, however, mount directories from the host operating system into the containers in order for the containers to access these files. Let's try to do that with nginx image. Containers and host operating systems do not share files. We can, however, mount volumes or directories from the host into the container for the container to access these files. Let's try to do that with nginx. If we go to the nginx on GitHub, on Docker Hub, we see that it uses this directory to show us some content. So if we create a directory that has an index.html and we told the container that this is your directory, so or basically we mounted it on the same place, then it should use our index.html rather than the one that exists inside the container. We are basically overriding the file system inside the container. I created a folder that's called HTML. Inside this folder, I created a simple index.html file. So if we go back, or basically we can stay here as well, docker run, we need to pass the option -v and the full path on the host. It will be root HTML, then column, and then the full path on the container. We have to also not forget to publish the ports, and then nginx. If we run this now, when the container tries to see the index.html that exists under user share nginx HTML, it is actually accessing the root HTML, our index.html. Let's see if that works. Refresh once, and it does. Another thing that we can override inside the container is the environment variable. Let's close this container first. We can, for example, pass something like, if this container depends on an environment variable that it uses to configure some application, we can pass the option minus minus env, and then the var, the value. In our case, this is not going to do anything, but in some images like Postgre or MySQL or some other images, they utilize environment variables to configure the application. This can be useful. The last trick that I want to show you today is how to access the shell within the container. We can do that in multiple ways. The first thing is if we have a container that's essentially a shell, for example, Ubuntu or Python or any operating system. We can do that by docker run minus minus interactive, or for shortcut minus minus I, and then minus minus tty, which I am not sure about, but I always use t. And then we want to run Python, for example. We can also specify the version of the Python that we want to use by specifying the tag, so 3.6, and we run it. Now it does not find the image, it's pulling it from Docker Hub library. It will take some time. What this does is launching an interactive shell inside the container. And since the default executable in this image is Python, we should be able to access the Python shell from the host and try some Python commands. Taking some time. Now we are in a Python interactive shell, so we can print welcome to space. Great. Once we exit the container, we know that it's gone. Alright, that was it for the first episode in the Container on Cloud series. We have learned few containerization concepts, we have installed Docker, and we have run our first Docker containers. I attached a list of the commands that we used today for you to check them out. If you have any problems running them, or if you have any problems regarding today's episode, please ask me in the comments section. If you enjoyed this video and you think that it's useful for you or for anyone else, please like it and share it with them. You may also want to subscribe to the channel to get updates about the videos that I will be posting weekly. Until then, have a good day. Ciao!